Let's dive into one of the most powerful and honestly most mysterious objects in the entire universe. And it all kicks off with a really simple but kind of terrifying idea. Just try to wrap your head around that for a second. Something so unbelievably heavy that it just breaks all the rules we thought we knew about space and time. Yep, that's a black hole. And that's what we're going to unpack today. We're going to look at what they really are, how they're born, and maybe the most fascinating part, what they can teach us about the secret rules of our universe. So let's get into it. Okay, first things first, let's get one thing straight. A black hole isn't, a literal hole in space. It's not empty. It's the exact opposite. It's a place where gravity has just gone completely off the charts. Gravity, right? It's the force that's keeping you in your chair right now. It keeps the moon circling the Earth and the Earth circling the sun. It's kind of the master architect of the cosmos. But what happens when you take that force and turn the dial all the way up to 11? So here's the secret recipe. It's all about density. You take a huge amount of stuff, like an unbelievable amount of mass, and then you squeeze it. You crush it down into a space that's impossibly tiny. When you do that, well, gravity just becomes this unstoppable force. Okay, so how do you even make one of these cosmic monsters? Well, the most common way, and it's a heck of a show, happens at the very end of a giant star's life. See, for most of its life, a star is in this constant cosmic tug of war. On one side, you've got the explosive force of nuclear fusion pushing everything out. On the other, you've got gravity trying to crush everything in. And for billions of years, it's a perfect stalemate. But eventually, for the really big stars, we're talking more than 20 times bigger than our own sun, they run out of fuel. That outward push from fusion just stops. And when that happens, the balance is gone. Gravity wins. And it wins in the most catastrophic way possible, causing the star's core to just collapse on itself. Think about this. You're taking the mass of an entire giant star and cramming it all down into a space about the size of a city. That's how you get this insane density. And boom, a stellar black hole is born. All right, so now we have our black hole. Let's talk about its most famous, and maybe its most terrifying feature, the point of no return. This isn't like a wall or a surface you can touch. It's an invisible boundary called the event horizon. And it's simply the line you cross where the pull of gravity becomes so strong that escape is impossible. Not even for light, the fastest thing in the universe. Here's a great way to think about it. Imagine space itself is like a river flowing toward the black hole. As you get closer, the current gets stronger. The event horizon? That's the edge of a cosmic waterfall. Once you go over, that's it. The current is too strong. There's no swimming back. So that leads to the inevitable, kind of creepy question, right? What would actually happen to you if you fell in? Well, science has a name for it, and it's weirdly descriptive. It's called spaghettification. Seriously. See, the gravity at your feet would be so much stronger than the gravity at your head that you'd be stretched and stretched and stretched until you were basically a long, thin strand of atoms. Not a great way to go. Okay, so this brings up a pretty big puzzle. If black holes are, by definition, black, they trap light, how in the world do we even know they're out there? That's the big question astronomers had to solve. And the answer is, you don't look for the black hole itself, you look for the clues it leaves behind. You look at the chaos it creates around it. So what are these clues? Well, for one, we see stars whipping around apparently nothing at incredible speeds. We can also see gas and dust getting sucked in, and as it does, it gets superheated and glows brightly in X-rays right before it disappears. And now we can even detect the ripples in space-time itself, gravitational waves, that are sent out when two of these things crash into each other. So for decades, all this evidence was indirect. It was compelling, but we'd never seen one. And then came 2019. This was a game changer. That was the year that humanity, using something called the Event Horizon Telescope, which is basically a network of telescopes all over the world working together to create a virtual lens the size of the Earth. We did it. We took a picture, not of the black hole itself, but of its shadow against that glowing, hot gas falling in. For the first time, this thing that was just an idea in an equation became real. We could see it.
And to really understand what we're looking at in that picture and what a black hole even is, we have to go back about 100 years to a guy you've probably heard of, Albert Einstein. So, Einstein had this radical idea. He said that space and time aren't separate things. They're woven together into this single four-dimensional fabric he called space-time. And he said gravity isn't really a pull. It's just the shape of that fabric being warped and curved by heavy objects. Think of it like a big, stretchy sheet. You put a bowling ball, that's our sun, in the middle, and it creates a little dip. Planets just roll around in that dip. But a black hole? That's not a bowling ball. That's something so heavy, it doesn't just make a dip, it rips a bottomless hole right through the fabric. A pit so deep that once you fall in, there is no climbing back out. So, black holes sound like pure chaos, right? Just these cosmic destroyers. But here's the crazy part. When you look at the physics, they are shockingly simple. On the outside, they look random, violent, chaotic. But underneath all that, the reality is they're governed by rules that are incredibly precise and, well, elegant. Think about how complex a star is, or a planet, or even you. A black hole? You only need to know 3 things about it to know everything there is to know. How much does it weigh, its mass, how fast is it spinning, and what's its electric charge? That's it. In a way, that makes them the simplest objects in the entire universe. And what some people take from this, what the source material we're looking at suggests, is that this deep order isn't an accident. It might point to a universe that has a really precise underlying structure to it, almost like a clean cosmic operating system running everything. But when you really stop and think about it, maybe the most mind-blowing thing isn't the black hole itself. It's us. The fact that your brain, your small human brain living on this little rock we call Earth, can figure this stuff out. That we can discover, predict, and even take pictures of these extreme objects. That right there is just incredible. So if we live in a universe that's governed by such elegant and beautiful rules that even the most extreme objects have to obey, what else is out there for us to understand? What's the next mystery we're going to solve?